Hello, this is Math Models, going over the notes for topic 1-6, talking about predictions and conclusions based on collected data. So, if we have data, we can make predictions. People use this all the time. There are people whose whole job is to get data and parse it out to make predictions. Fantasy football hinges on taking data and making predictions. So let's go ahead and look at example number 1. Here we've got the Tomball Titans. We don't know what game they're playing, but they've won 2 of their games and lost 8 of their games. And we want to know how many games they must play to win 7. So we're looking for a total number. So, how many games have they played so far? Well, so far, 2 plus 8 equals 10 games. They've played 10 games so far and they've won 2. So I can go ahead and write a proportion of 10 wins to 10 games. Now, I don't know how many games I need to win, but I do know that I want 7 wins. And here I have just a simple proportion that I can cross multiply and divide. 70 divided by 2 makes 35, and so we need to play 35 games just so that we can have 7 of them as winning games. Obviously, the Tomball Titans are not having a very good season, so this just doesn't look very good, and they know already they've got to make some major changes. Let's go ahead and take a look at example number 2. Well, in the past 3 months, Miss Williamson has lost 20 pounds. And now, we want to know how much longer to lose 50 more. Well, for 3 months, we've lost 20 pounds. And we know that we want to lose 50 more pounds. And we want to know how many more months. So we're not dealing in totals anywhere. Here we're dealing with more months and more pounds. So we just do the cross multiply and divide again. And 3 times 50 divided by 20 gives us 7.5. So it's going to take her 7.5 months to lose that additional 50 pounds. So Miss Williamson can look at this, see what she's done, realize if she keeps up the same thing she's been doing, it's going to take her 7.5 more months. And if she wants to lose more weight than that, then if she wants to lose that weight in a shorter time span, then she's going to have to start doing more, either more diet or more exercise. So that's making predictions based on our data, which is pretty easy. However, we have to collect our data and then make sure that our data is accurate. And here we're talking about surveys. When you conduct a survey, you want to make sure that your data is valid, which is just another way of saying accurate. And the accuracy or validity of your data depends on how your data was collected. Okay? So this is the survey that we use to conduct our information about a particular group. And then we want to talk about some of the vocabulary terms. We have our population, which is the entire group of individuals. And then we have our sample. That's who we actually go out to ask. Now, In a perfect world, you go ask everybody, know your answer exactly. Schools will do that with lunches. They will ask everybody what they want for lunch so that they can know exactly how many lunches to make. Um, Other schools do it based off of past data, and based on how this stuff is sold in the past is how much food we need to make now. And they can do that really well without having to collect all that information. But usually, the way we do this is we will ask a sample. So, if someone's running for president, all these different polling services will run different types of polls and figure out who they think is going to win the presidency based off of that. And they don't ask every voter in the United States. They just ask uh, their sample, which is still a fairly large number because they want to make sure their data is accurate. So they ask their sample, and they can make a prediction. And sometimes it's accurate, and sometimes it's not. It all just depends on the bias, which is what we will be talking about next. So these are some surveys that are just inherently biased. The first one is the call-in opinion polls. So television news programs, radio news programs, uh, they will make a call for public opinion. They'll say, for example, what do you think of this latest political event? Okay? Basically, what do you think? Right? And so they'll have you call in, and maybe it's a yes or a no question, and it could be, do you have pets? Okay? And they can get a whole bunch of people calling in, and they'll get their polls, and their polls say 67% no. Okay, 67% people don't have pets, according to their poll. But in reality, it could be that 72% do have pets. And this can be biased in several different ways. They only have certain people who listen into their radio show, and maybe the guy was talking about how much trouble pets are, and people are calling in to agree with him, saying pets are too much trouble. No, I don't have any. Uh, some examples of these would be like American Idol. Okay, they say call in and say who you want to keep. We'll get rid of the person who has the least amount of votes, and they get rid of somebody, and maybe they got rid of somebody that actually a lot of people liked. They just didn't take the time to call in or go online. Another example would be like a radio show call in. Okay. You have to be watching the show and feel the need to call in. So there's just lots of bias in these call-in surveys, and you really can't trust their information. Now, a voluntary response survey is a little bit better than a call-in opinion poll. These are people who decide, you know what, I am going to respond to the survey. And so these are biased really because you just get people with strong opinions, especially if those are negative. And so if you're talking about drug testing in athletics, you're going to get people who very strongly believe in it. You're going to get a bunch of athletes talk about it that don't like it because it's an additional thing they have to go through. Whereas if you're talking about the school calendar, well, usually not a whole lot of people have extremely strong opinions about that. And so, here are, just thinking of some voluntary response samples. That would be like a mail-in survey. Okay? Or an email survey. or really even phone surveys. A lot of people will just hang up and not do the poll. And because these people are hanging up, well, we're only getting those people who have strong opinions, negative opinions, or have a lot of time on their hands and feel like taking one. Now, another one is interviewing at the mall. And companies will do this because it helps them determine what to sell and if this ad is working. It's really cheap. They can just hire one person to come in and do it. But you're not going to get the whole nation. You're going to get people who are richer. They can afford to go to the mall. You get teenagers who like to hang out, or retired people who don't have a whole lot else to do. And your mall interviewers are probably not going to ask the person who looks like they just walked out of prison. They're going to be looking for the nice, neat, and safe customers and not step out of their comfort zones. So this might be, some guy who's standing, like, at the movie theater. Movie theater survey. Those ones that you have out front of the movie theater. Or it could be a sales representative. Passing out flyers. That kind of thing. Generally, we're wanting people to be asking questions. So we've talked about these different surveys and talked about their bias. Let's go ahead and look at what might be wrong with this survey. So a sociologist wants to know the opinions of Texas teachers about government funding for high school sports teams. So she gets a list of high school teachers from Bryan and College Station, then mails them a questionnaire to 100 of the randomly selected teachers, and 42 are returned. Well, let's look at what our different things. Our population, that would be Texas teachers. So we want to know what Texas teachers think, but our sample is 42 Bryan or College Station teachers. So we want to know what all the teachers in the state of Texas think, but we're only asking 42 of them from Bryan or College Station. Okay, that's all the information we got. So this is biased, and the question is, why? Well, first off, we only asked 2 schools. Okay, we only asked 2. We didn't get Livingston or Houston or Austin. So what needs to be changed? Okay, we need to send surveys to other schools. Okay, the randomly, that's good. Okay, but we need to do it, 50 surveys to several schools. Okay, and while we can't hit every school in the nation, because that would just be ridiculous, we want to make sure that we hit large and small schools. Ask large and small schools. Okay, small schools may have a different opinion on government funding for sports than large schools. So let's go ahead and take a look at these pictures. I'm going to zoom out a little bit so we can see both pictures. These tables look very different, but they're actually giving us the exact same information, and they have bias. And so we've got some, on the next page, we've got some blanks for you to talk about misleading. And so this is graph number 1. and this is graph number 2. And let's look at why they are misleading. Well, graph number 1, if you notice, it starts from 100 and goes to 210. So this value is 120, and this value is 200. It only went up 80. So this looks like it's skyrocketing, but it only went up by 80. So this one is biased because the graph goes from 100 to 210, and it shows a steeper, and it makes it look like it's increasing more than it is. So let's go ahead and write that down. Graph 1 makes the line steeper than it should be because it starts at 210 instead of 0. But now let's take a look at graph number 2. Well, graph number 2 is also biased. I want you to look at all of this white space up here. This graph looks like nothing has changed. I mean, it's good, it starts at 0, but it goes all the way up to 500 when our biggest number is about 200. So while this is better, it's not lying that cancer is skyrocketing. It's still not accurate because our graph goes all the way up to 500 when it really only needed to go up to about 250. So graph 2 is better. But the line is not steep enough because it goes to 500 when it only needed at most 250. Half that graph is useless to us. And I don't have a third graph for you to make this third example on, so we don't need to fill it out. But think about bias and whether or not your data is accurate before you go on trying to make your predictions. Good luck on the assignment. Have a good day.